In 2023, the International Monetary Fund issued a warning that echoed through boardrooms and living rooms alike. Nearly 40% of global employment was highly exposed to artificial intelligence. But fast forward to today, and the conversations inside corporate finance departments sound very different. Instead of counting the billions saved by replacing human workers, executives are staring at enterprise technology budgets that are spiraling out of control. The costs have become so extreme that Microsoft temporarily banned some of its own employees from using certain coding AIs. Running these massive models for everyday tasks is like driving a Ferrari to commute from your bedroom to your kitchen. It works perfectly, but the gas bill will bankrupt you. We are collectively confusing an algorithm's technical capability to do a job with the economic reality of a business actually being able to afford it. To find out exactly what businesses can afford, researchers at MIT and the Oak Ridge National Laboratory built Project Iceberg. They used the Frontier supercomputer to create a massive digital twin of the entire U.S. labor market, testing exactly where automation actually makes financial sense. The simulation ran the numbers on over 32,000 skills across nearly 1,000 occupations. The result? Right now, it is only profitable for AI to replace about 12% of U.S. labor wages. A machine might have the processing power to do your job flawlessly, but that doesn't mean your employer has the capital to buy, run, and maintain that machine. MIT researchers explain this using the tripartite analytical model. Think of it as a massive filtration system that every single job has to pass through before a human worker is actually replaced. The first filter is pure technical performance. Can the AI actually do the work? For computer vision and text tasks, the technology is incredibly sharp. Roughly 80% of the work breezes right through this first layer. But then those tasks slam into the second filter, system characteristics. An off-the-shelf AI model is virtually useless to a large enterprise without highly specialized company-specific context. To make the AI useful, companies have to pay for last-mile customization. They have to fine-tune the models, build secure vector databases, integrate proprietary APIs, and set up strict data guardrails. Even as raw computing power gets cheaper every day, paying specialized software engineers to integrate that data locally requires a massive amount of upfront capital. Clearing the technical bar is relatively cheap. Building the custom infrastructure to safely run an AI inside a specific company's ecosystem is where the costs begin to multiply. If a project survives that, it faces the third and final filter, the economic choice. The custom AI system has to prove it costs less per task than the fully loaded salary, benefits, and overhead of a human worker. This calculation comes down to the minimum viable scale. Because AI requires such immense fixed upfront costs, a company needs an enormous volume of repetitive tasks to spread that expense across, just to break even. Imagine a local bakery where a human spends a fraction of their day visually inspecting bread for quality. Now compare that to a massive industrial plant, churning out tens of thousands of identical loaves an hour. The local bakery cannot mathematically justify spending $100,000 to build a custom computer vision system just to automate 6% of a baker's $48,000 annual salary. They simply don't have the volume. And even at scale, there is a final hidden expense, the human-in-the-loop tax. Because AI still hallucinates and struggles with edge cases, companies have to keep humans on the payroll to audit the algorithm's work. Paying someone to double-check the machine eats directly into the expected cost savings. Unless a business processes an industrial-scale volume of data, keeping a human employee is simply cheaper and much more flexible than trying to pay off a multi-million-dollar algorithmic system. When the entire U.S. labor market is processed through all three filters, the math is sobering. A tiny trickle, just 11.7% of wages, drops out the bottom of the funnel as economically viable to automate today. The jobs that make up that 12% share a very specific profile. They are roles defined by massive transaction volume, high repetition, and a very low cost of error. Think mass invoice processing or high-speed data sorting. Economists call this the new solo paradox. The paradox describes a frustrating economic reality. A technically superior technology will completely fail to be adopted if the financial entry barriers and daily maintenance costs are prohibitively high. The AI transition will unfold as a slow, rolling process over decades. its pace dictated by the gradual decline of computing and data integration costs. If your job feels safe today, you are simply a more economically efficient algorithm than any machine your employer can currently buy.